Okay, so in this video, we are going to look at calculating concentrations of acids and bases. This is going to look exactly the same as it did when we were calculating concentrations of solids when we were back in the solutions unit. So you're going to start by listing your givens. You're going to think about what unit you are trying to get. You're going to start your unit analysis with something that has that unit, and then you're basically going to eliminate until you're left with just your unit. In some cases, it's going to ask you to calculate the concentration of either the hydronium or the hydroxide ion. This is going to look exactly the same as it did as in the last unit when we were looking at calculating concentration of ions. You are going to have to write an equation. Whether it's an ionization or a dissociation equation will just depend on whether you have an acid or base. And then you are going to use your ratio in your calculation to help you switch those units over, okay? So exact same thing we did before, we're just switching it over from like ionic compounds over to being acids and bases. Okay, so here we have our first example. So what is the concentration of hydrochloric acid if 3.50 grams of HCl gas is bubbled through 3 liters of water? Okay, so we're going to start by listing our givens. We were given a mass as 3.50 grams. We are given a volume as 3 liters. Okay, if you look at your units, right now you only have the ability to get grams per liter. Okay, we're trying to get concentration, and you're going to find that when we are doing this, we're always looking for moles per liter. We're not worried about some of those other ones that we talked about in the last unit. So the only way I'm going to be able to get moles and get rid of grams is to go get the molar mass for that hydrochloric acid, right? So we have hydrogen, which is 1.01, and then we have the chlorine, which is 35.45. That gives us a molar mass of 36.46 grams, and that is going to be per mole. Okay, so now we've listed all our givens. We can go ahead and start doing our unit analysis. So we are looking for the concentration of that hydrochloric acid. And that means we want to get moles per liter as our final set of units, right? So mass isn't really a great one to start with because it has grams. There's no moles, there's no liters in that, so I don't actually know where that needs to go. Okay, next I look over here at volume. Okay, well this has liters in it. If we think about our unit, we know that it's going to be moles per liter, so we know that that liters needs to get placed on the bottom. So we're just going to flip it over, right? We're going to put a 1 on top. We are going to put that 3 liters on the bottom. Okay, that's going to ensure that we now have liters on the bottom where they need to go. So now what we need to place is that moles, right? So again, mass doesn't help me. It doesn't actually have moles in it, but molar mass does. There's that mole in there at the bottom. So that moles needs to be on the top. So we are going to flip it over, right? We're going to put the moles on the top, and on the bottom, we're going to put that 36.46 grams, okay? So now when we look at this, we have the units of moles per liter, which we want, but now we have the grams down here, which we need to get rid of. So to be able to get rid of the grams, we're going to times by that mass, right? Remember we talked about how to be able to eliminate a unit, it needs to be in the opposite spot. So because right now grams is on the bottom, this grams is going to have to go on the top. So we're going to put 3.50 grams on top, and we can just put that over 1, right? Now when we look at our units, we can cancel the grams, and we're left with moles per liter, okay? We're going to calculate it, see what our answer is, right? So when we type that in, we're going to do 1 divided by 3, then divide by 36.46, and then times by 3.5, right? Remember, everything on the bottom we need to divide by, everything on the top we get to multiply by. So we get that it is equal to 0.03 significant digits. We get to have 3, so 20 moles per liter. Okay, so that's going to be our answer, 0.0320 moles per liter. So should be looking more or less exactly the same as the calculations you did in the last unit. The only difference is it was an acid, but even at that, it didn't really change anything that you did. Okay, so Now we have different examples. So what is the hydronium concentration in a solution of HClO4, which has a concentration of 2.25 moles per liter? So we're being asked to find hydronium, right? That's an ion. So we are going to have to start by writing out our ionization equation. Sorry, my dog is joining me on the couch here. Say hi, Chloe. So we're going to start with that HClO4. Okay, this is an acid, so it's going to be an ionization equation. So we're going to do plus the water. And then we're going to throw our arrow in. Okay, and this is going to form hydronium. And I don't know what button I keep hitting that does that. And that ClO4 minus ion. Okay, so givens wise, what we have been given is the concentration of the HClO4, right? So I know over here that this is 2.25 moles per liter. Right, and we are looking for the concentration of this hydronium ion, right? That is our unknown. So when we think about what we are trying to get, we're trying to get the concentration of that hydronium ion. So it's going to have units of moles per liter, which is the same as the units of this. The difference is we need to make sure it's moles of hydronium per liter. And this, because it's written with HClO4, is moles of HClO4 per liter. So we need to switch the moles of HClO4 over to moles of H3O+. We do that using our ratio, right? So what we're looking for on the top, so 1 mole of that hydronium. Okay, we also configure that the hydronium needs to go on the top because we know unit-wise we're looking to get moles of H3O+ per liter, right? So ratio, what we're looking for on the top, what we know on the bottom, what we have info for is that HClO4, and it's going to be 1 mole HClO4. Okay, 1 and 1 because this equation balanced with ones, right? That's where these ratio numbers are coming from, is what numbers did I use to balance it. Okay, looking again back at our units, we've now placed the hydronium ions. We need to get rid of that HClO4. We also need to place the liters. So simplest way to do that, we're going to use that 2.25 moles of HClO4 per liter. Okay, looking at those units, we get rid of moles of HClO4. Okay, in this case, because it was a 1-to-1 ratio, we are getting the same answer at the end. Okay, usually someone will always be like, oh, if it's a 1-to-1 ratio, do I actually have to show it? You should. You should always show that you recognize something is 1-to-1, because there are definitely situations where things are not 1-to-1, and if you just always assume that they are and that you're okay not to do something, you're probably going to wind up making some silly mistakes. So this question here should have looked more or less exactly the same as the ratio questions that we did when we were back in the solutions unit, right? We knew a concentration, we were looking for a new one, so all we had to do was that ratio to be able to convert it. All right, here's our next one. So what is the hydronium concentration when 2.25 grams of HCl is dissolved in 100 mils of water? So again, we're being asked to find that hydronium concentration. So we're going to have to write our ionization equation, right? So that HCl plus water, this is going to give us our hydronium and our chloride ion. Okay, so things we know. We were given a mass of HCl, right? We were told 2.25. Okay, we were also told the volume, so we know that it was 0.100 liters. Okay, we're trying to get the concentration of this hydronium. Okay, because we have mass over here for HCl, we're also going to have to go get molar mass for it. So 36.46 grams per mole. Okay, so we need to go about actually doing our calculation for this hydronium ion. So unit-wise, right, we want to get moles per liter, and specifically we want moles of hydronium. So same as before, I can choose a couple of things to start with. I can either choose by starting by placing the moles of hydronium, or I can choose by starting to place the liters. It doesn't really matter which one I choose. So let's start by placing the moles of hydronium. So when I look right now, the only given I have with moles is HCl, but I don't want moles of HCl, I want moles of hydronium. So how we're going to do this is we're going to use a ratio. Okay, you're going to find that pretty much any time you're trying to find the concentration of an ion from a starting thing, you always need that ratio, okay? So we're going to have 1 mole of hydronium, right? Because like we've talked about before, we know unit-wise we need it on the top. We also know that what we're looking for should be going on the top. On the bottom, what we have the info for, that 1 mole of HCl. So the other reason why it has to be moles of HCl is I have to be able to cancel it. Right, if I put 1 mole of Cl minus in here, I don't know anything about that chloride ion, so I don't actually have anything left to actually be able to cancel that out with. Whereas mole of HCl, if you look at HCl, you have moles under there, so we can use that to cancel this. And that's what our next step is going to be. We're going to use that. So we're going to flip it over and do moles of HCl over that 36.46 grams. Right, from that, we can cancel the unit moles of HCl. Okay, next thing we need to cancel is going to be grams. So because grams currently on the bottom, we need to make sure that we have grams on the top. So we're going to put that 2.25 grams on the top, and we can just throw that over 1. So now we can cancel out the unit of grams. So when I look at those units, right now I just have moles of H3O plus, everything else is gone. But we know we're trying to get moles per liter. So we got the moles part, we just need to bring in the liter part, and we're going to do that using the volume. So we're just going to say times, we know the volume needs to go on the bottom, so we're just going to put 1 on the top, and then on the bottom, we're just going to put our 0.100 liters. Okay, so that's going to take care of now positioning those liters down on the bottom for us. So when we look at our units, we now have moles per liter. Okay, so we need to calculate this. So in your calculator, remember, usually those ones don't matter. The only one in this case that I really need to make sure that I'm actually using is this one, because otherwise my first operation is to divide by 36.46, and I can't do that. Okay, so 1 divided by 36.46 times 2.25, and then divided by 0.1. We go ahead and get our answer, and it is equal to 0.617 moles per liter. Okay, so again, this looks really similar to those calculations that we did in the solutions unit. Okay, you're going to find that once you figure out unit analysis, we use that for everything. Okay, when we're looking ahead into next year, right, one of the really important things for you guys to be able to do is going to be to do your unit analysis, which we're working on now. We're going to work in the stoich unit, and to be able to do those pH, POH things. Okay, so I know some of you are kind of concerned of like what are important things that you need to make sure that you really understand for next year. And I would definitely say that solutions and stoich are those kind of 2 major units which really are important in Chem 30. Okay, bonding, which we've already done, doesn't have too big of an impact in Chem 30. It maybe comes into play with a couple of things in the organic unit. Gases, which is going to be our last unit, really doesn't play into Chemistry 30 at all. But stoich and the solution stuff and the acid base of the solution stuff are really where you want to focus your attention and make sure that you feel confident with it. So if you find you're really struggling with this unit analysis, please take the time to send me an email so we can maybe set up like a little video conference or something, because this is super important if you plan on taking Chem 30 next year. But if you already know you're not planning to take Chem 30 next year, then it's not as big a deal to make sure that you have that strong foundation in it. But if you're planning on taking Chem 30, this is super important to make sure that you can do these types of calculations. Okay, last example. So what is the hydroxide concentration if 1 gram of calcium hydroxide is dissolved in 500 mils of water? So same idea again, it's asking for the hydroxide. So that's an ion, so we're going to have to start by writing out an equation. So all the other questions we've done have all been ionization equations. But calcium hydroxide is this, right? This is a base. So bases don't undergo ionization, they undergo dissociation, right? Which is why we put our arrow, and over that arrow we put that water to show that it is being dissolved in it, okay? Okay, this is going to break apart. The ions we're going to get a calcium ion, so Ca2 plus Aq, and we are going to get 2 hydroxide ions. Okay, so again, we talked about writing these dissociation equations. Really important to make sure that you can write them. So question is asking us to determine the concentration of hydroxide ions. So that's what we're looking for. Things we were given the mass of calcium hydroxide is 1 gram. And we were told that we had 500 mils, which is equivalent to 0.5 liters. Okay, once again, we have that mass for calcium hydroxide, so we are going to have to go get a molar mass for it. So do that, right? So we do the 40. Oh, that button didn't type. Of course, I left my calculator in the school, so I'm using my high-tech cell phone calculator. But if you find yourself in the same position, there is a TI-84 app that's free that you can definitely get for your phones. It works pretty similar to that TI, right? So if you have a TI, this probably looks more or less like what you're looking at. So it is an option for you. Normally we're like, oh, don't use calculators on your phones because we won't let you use them on a test or anything, but obviously right now you are not writing a test. So if you find that you have forgotten it, that definitely is a pretty good one that you can use that's able to do all of these calculations. I don't think it'll graph if you're currently in math class, but it has more or less the ability to do everything that we need you to do for Chem 20. Okay, so back to this example. We are trying to calculate the concentration of that hydroxide ion. So again, we think about the units that we're looking for. We're looking to get moles of hydroxide per liter. Okay, so we have moles here, but this is moles of calcium hydroxide. I don't want moles of calcium hydroxide. I want moles of hydroxide. So we start with our ratio. So 2 moles of hydroxide. And it's 2 because when we balanced right here, we put it 2 into that, okay? And that's going to be over 1 mole of calcium hydroxide. Okay, so now we've got this ratio that places our moles of hydroxide. We need to get rid of moles of calcium hydroxide. We can do that by using our molar mass. So moles of CaOH2 over that 74.10 grams. Okay, so now we can eliminate moles of calcium hydroxide. We now have moles per gram. We don't want moles per gram, we want moles per liter. That's okay, because we can get rid of grams, right? We can get rid of grams using mass. So I can use that 1.00 grams. Same as always, we'll just put it over 1. Now when I look at it, my grams can cancel. Now I just have moles of hydroxide. I need to introduce that liters. So we're going to do times 1 over, and then we'll place our liters down here. Now when we look at all our units, they've all canceled except moles of hydroxide per liter. So we know that we have set up our equation properly. Okay, so in our calculator, we're going to do 2 divided by 74.1 times 1 divided by 0.5. Okay, and that's going to give us 0.0 0.540, right? We had to round that because of the numbers we had in the significant digits, okay? So really important to make sure that you can do all of the stuff in this video before you move on to the pH stuff. Okay, to be able to do the pH stuff, you have to be able to do the calculations that you see here. Okay, you have to be able to calculate the hydronium ion concentration as well as the hydroxide ion concentration. Till you can do that, I would hold off on watching the next video just until you feel as though you have a good grasp of this. If you're like, nope, this was easy, I feel really comfortable with this, then by all means go ahead and you can watch that pH video to kind of see what the next step is in these types of calculations, okay?